So we're going to talk about half-angle identities. So these identities here. So my videos, first I just prove the identities and then I go through different exercises that use them. So just to start with how to prove them. So to prove, or just to show you like sine of a over 2, where does this come from? This actually comes from the double angle identities. So I'm going to start with cosine of 2x equals 1 minus sine squared x. And so yes, we do start actually with cosine of 2x. But remember, with the double angle identities, there were like a bunch of different ways you could think of cosine of 2x. And I'm being strategic in the fact that I've chosen this particular identity, because what I'm going to do is I'm going to solve for sine squared x. Okay, so if I go through and do that, so I'm left with this, and then I can divide everything by 1/2 or multiply everything by -1/2. So I get sine squared x would equal this, and if I wanted to write this, let's get myself some room. If I wanted to write this as a fraction, so I'm just going to write all of this now over the fraction of 2, and then I just reverse the order, so this becomes 1 minus cosine of 2x over 2, so I've got sine squared x equals this, okay? And so then you know how to finish solving this, right? So we're trying to solve for sine squared x. So I can just take the square root, and remember this is plus or minus because that's the square root property, so it's always going to be plus or minus. So you get this. And okay, now the last thing that I'm going to do, and this is probably like the one kind of tricky part, I guess, because solving for sine, we can solve for sine, no problem. But how do we actually get to that identity? So what we do is we actually make a very clever substitution, where the substitution is where you see 2x, we're going to replace it with a. And then if 2x equals a, then also we can say that x equals a over 2, right? So I just solve for x. So where I have this x, I'm going to replace it with a over 2. And then where I have this 2x, I'm going to replace it with a. And now, boom, we have our identity. So that's how that one is created. You really just solve for sine and then you make that substitution. Now, with this particular identity, we have plus or minus, and remember you get the plus or minus, and you choose based on quadrant. If you don't have any quadrant information, then you would keep the plus or minus. So just a note on that. Okay, so let's talk about cosine of a over 2. We're actually going to use the exact same strategy, so we're going to use cosine of 2x, but now I'm going to cleverly choose 2 cosine squared x minus 1. I'm going to use this particular identity, but we're going to go through the same motions. So we're going to solve for cosine of x. And so I think that you guys know how to go about solving for that. So I'll just show you what it looks like when we've solved. And then we do that same substitution thing again, where I'm going to have my x be a over 2 and then my 2x be a. And so then that's how you would get the other identity. And so then the last one that we have to worry about is tangent of a over 2. So we actually have a few different options for this. So one way we could think about this is tangent of a over 2. This is equal to sine of a over 2 over cosine of a over 2. So I just use that quotient identity for tangent. And then I can write out what those two identities were, what we just found, right, what we just proved. And from here, I have that the 2's cancel. So these square root of 2's cancel, so that I'm just left with this square root here, this square root over this square root. And I can just put this all under the same square root so that I get this identity. So this is one way that we could think about tangent of a over 2 is plus or minus the square root of 1 minus cosine of a over 1 plus cosine of a. But there's other ways we can think about this. So if I want to think about this in another way, so again, I can still approach from this sine over cosine strategy, but what I'm going to do is something a little odd. I'm going to very cleverly multiply by 2 cosine a over 2. So I multiply both the top and the bottom by this. And then I just sort this out. So what I get then is 2 sine a over 2 cosine a over 2 on top, and then 2 cosine squared a over 2. And so now we can refer to the double angle identities for a moment. So that 2 sine a cosine a, that's very similar to what we're looking at in our problem right now. So I can use this particular identity. And then the other identity that I'm going to use is this cosine 2a equals 2 cosine squared a minus 1. I'm just going to solve for the 2 cosine squared a, though. I just rearrange this to be cosine 2a plus 1. And so then I can make those substitutions as you see here. So now, having used those identities, I can just do this multiplication, right? 2 times a over 2, 2 times a over 2. What does that become? Well, that's going to then just turn into sine of a over 1 plus cosine of a, because the 2's will cancel out. So tangent of a over 2 is also equal to sine of a over 1 plus cosine a. And we can do this one more time. So I have one more identity. So using the identity that we just talked about, sine of a over 2, sine of a over 1 plus cosine of a. So we can multiply by the conjugate here. So if I multiply everything that you see here by the conjugate, and I just multiply it all out. So I get this result here. So sine of a minus sine of a cosine of a over, and then if I FOIL this out, this works out to 1 minus cosine squared a. Now, 1 minus cosine squared a, that's our Pythagorean identity, right? So this will equal sine squared a, so I can make that substitution. So let's see, okay, so just giving myself a little more room. Okay, so here's that substitution, and now you notice I've got sine, sine, and sine, so I can go ahead and I can cancel out one factor of sine throughout this whole problem. And when I do that, I'm left with 1 minus cosine a over sine a. So we also have that tangent of a over 2 equals 1 minus cosine a sine a. All right, so in summary, these are all the half-angle identities. So I put them all in one place. So of course, if you want to write them down, which, you know, if you're watching this video, I'd suggest that you pause and write them down. We're going to use these now in a bunch of different exercises. Okay, so let's start with the first one. So first, I just want to get you used to using the half-angle identity, because I know it's a little weird to like look at and to interpret. So I want to just help you wrap your brain around it. So we're going to use the half-angle identity for sine of 12.5 degrees. And all I want you to do is just get yourself acclimated to actually using this. So remember, this needs to ultimately be in the form a over 2. So 12.5 is equivalent to 25 over 2. So this is the way that you want to treat these types of identities, is you're usually going to multiply this number by 2 and then rewrite it as you see here. And from here, then I can just go ahead and apply my identity. So I can apply this identity here. So now that I have 25 in this spot, I can just apply the identity as you see. And so I would get plus or minus 1, the square root of 1 minus cosine of 25 degrees over 2. Okay, so that was just to kind of get you acclimated to using this identity, or these identities. So now I want to find the exact value of cosine of 165 degrees. Okay, so what I would recommend that you do, we're working with cosine here, I would recommend that you try using this half-angle identity. Just try setting it up and plugging everything in and seeing what you can do from there, just to get your brain acclimated, and then hit play when you're ready. Okay, so cosine of 165, if I multiply that by 2, I get 330. So I rewrite this as 330 degrees over 2. And then, like I said, I'm going to use this identity here, and I'm just going to plug everything in. So I get plus or minus 1 plus cosine of 330 over 2. And, okay, so now if I go to look at that, so using my unit circle, here's 330 degrees. So here's cosine of that. So, okay, so now I can go ahead and just plug all of that in. And so when you are working through these, sometimes you're going to find that you have a fraction within a fraction. So this is not very pleasing to look at, this particular answer. So we do want to simplify here. So now we've got to get our algebra chops up a little. So what we're going to do is we're going to multiply the top and bottom by 2, because notice in this strategic choice of 2, that will cancel out the denominator down here. So, okay, so then I multiply everything by 2, so this becomes 2 plus square root of 3 over 4. But what can I actually take the square root of in here? I can take the square root of 4, so I can actually simplify this to plus or minus square root of 2 plus square root of 3, all of that over 2. So there you go. Okay, so now let's find the exact value of tangent of 75 degrees using tangent of a over 2 equals sine of a over 1 plus cosine of a. So you've even got the identity in this case. Once again, I would recommend that you just pause the video here and then try to work this one out. Hit play when you're ready. So I can rewrite this as tangent of 150 degrees over 2. And then I'm just going to plug in that 150 into this. And from here, I can simplify, right? So I can take 150 and I can just read off the coordinates here. So what I'm going to be left with then is 1/2 over 1 minus square root of 3 over 2, right? Because cosine of 150 is negative. So notice I change this to a negative down here. And then I can go ahead and try to simplify. So once again, I want to get rid of all my fractions. So I multiply the top and bottom by that denominator. I multiply it by a number that will clear the denominator. So when I do that, I'm left with 1 minus 2, or 1 over 2 minus square root of 3. Okay, are we done? We're actually not. So now we've got to mess around a little bit with rationalizing. So I just want to remind you, how do you rationalize something like this? You multiply by the conjugate, so 2 plus square root of 3 on top and on bottom. So if I multiply those things out, I get 2 plus square root of 3 on top, of course, and then in the bottom, I get 4 minus 3. So that just becomes a 1 in the denominator. So ultimately, this equals 2 plus square root of 3 after I rationalize. Okay, so the next exercise is to look at given cosine of s equals 2 over 7, and s is between 0 and pi over 2, so that's quadrant 1. We want to find sine of s over 2, cosine of s over 2, and tangent of s over 2. So I know I've done a lot of exercises like this in other videos. I want to just remind you what the identities say before I get too far into this. So notice with these identities, that all of these are using cosine of A. So this identity, and this identity. So that's important to recognize because what that tells me is I can actually just use this cosine. I don't have to draw a picture like I do in some of the other problems. I don't have to figure out the other sides. I can just leverage the identities that are already using that cosine value. So that's kind of what I wanted to point out there. Okay, so now let's just note one other thing, might be kind of important. So we know that s is between 0 and pi over 2. So if that's true, if I were to divide everything by 2, I would have 0 is less than s over 2, which is less than pi over 4. This is still in Q1. So you just want to notice where is your s over 2? What quadrant does that fall in? Sometimes it will stay in the same quadrant. Other times it might get moved to a different quadrant. So just a word to the wise there. Okay, so I've just kind of noted that over there just in case I need it. Okay, so now let's go ahead and let's evaluate sine of s over 2. And I want you to notice that when I wrote out this identity, I actually just went ahead and wrote it as the positive one. I don't have the plus or minus. Why am I doing this? Because I figured out that this was in quadrant 1, so I can take a liberty now in that this square root will end up being positive. Okay, so here's the identity, and now remember, I know cosine of s. That was actually given to me, so this is what I mean when I say that you don't have to redraw the picture. I can just plug in that 2 over 7, and then I can simplify all of this. So what I'm going to do is that same trick you keep seeing me doing, so I'm going to multiply everything by 7 so I can clear the fraction. So I'm left with this calculation here. 7 minus 2 over 14, and I'm taking the square root of all that. So of course I get square root of 5 over square root of 14, and then you've got to rationalize, so you multiply the top and bottom by the square root of 14 to get square root of 70 over 14. Okay, so that's sine of s over 2. So now let's pivot to cosine of s over 2. And again, notice like all I need to know is the value of cosine of s, which was given to me. So I think personally that you can finish this one. And notice again, I was able just to say that this is positive because we know that we're in Q1. So anyways, I think you should try this one totally on your own since math is not a spectator sport. Give this a try, evaluate all of it, and then just hit play when you think you've got it. So, okay, I'm going to plug in that 2/7, and then we're just going to go through the exercise of trying to rationalize. I like to clear the fractions, so this really comes out to 7 plus 2 over 14. So I get square root of 9 over square root of 14, and then I can multiply both sides by the square root of 14 to get square root of 126 over 14. Okay, so now that we've done those two, so we can do tangent of s over 2. There's a couple different ways that we could deal with this. I'm going to show you. So one way that you could deal with it, which maybe actually would be a little bit better, but I wanted to just show you other ways you could do it. You can use this identity here. That would have been totally fine. But just to mix it up, you know, for funsies, I can also use the previous values that I've found. So if I do that, I get square root of 70 over 14 and then square root of 126 over 14. So I could just simplify this, and then I could go through and I could do the work to rationalize this. So I multiplied the top and bottom by the square root of 126. I would get this crazy answer here, and then I can actually simplify this square root on top to 42 times the square root of 5, and then 42 goes into 126 3 times actually. So this whole answer just simplifies to this. So I bring this up because you have a built-in check here too. So this was me using the answers that I computed. This square root of 5 over 3, that should in theory match and be the same answer as if you were to compute this. So you have a little bit of like a built-in check for yourself, and I'm going to leave this check to you if you want to try calculating that out to see if you get the same thing. But just a note there, like if you are nervous about some of these answers, which I mean, who wouldn't be, you've got just a lot of calculation going on, this is a good way to just double check yourself. Okay, so the next set of exercises, I just want to kind of get you used to now simplifying expressions. And so this is all going to be just you relying on looking at the half-angle identities. So I've got square root of 1 minus cosine of 40 over 2. So if I look at my list of half-angle identities, so here's where I've got my minus cosine, so I'm going to use this identity here. So then I can go ahead and plug this in, so this becomes sine of 40 over 2, so this will just equal sine of 20 degrees. Okay, so why don't you try the next one? So you can just look through your identities and then just try to simplify this one. You can hit play when you're ready. So in this case, in my half-angle identities, I'm using this particular identity here. So then if I were to just plug everything in, so I get tangent of 64.72 over 2, and so that will simplify to tangent of 32.36 degrees. Okay, and last one, so again, just look through your list of identities. Again, math is not a spectator sport. If you're trying to really learn this, then you've got to engage a little bit. So try this one, hit play when you're ready. Okay, and going back to my half-angle identities, so now I'm going to use this identity here, so I can just plug this in. So this becomes cosine of 10x over 2, so I get cosine of 5x when I simplify everything, so we're good to go. Okay, and what would an identity video be without verifying some identities? So I just have 2 identities here that we are going to verify. So I've got cotangent squared of x over 2 equals 1 plus cosine x squared over sine squared x. And I don't know, I guess I'll just start with this side. It looks maybe like it's slightly more complicated. So if I were to just rewrite this in terms of cosine and sine, I would get this right here. Okay, okay. So now I've squared both of these, right? And these are literally using my half-angle identities. So I can go through my half-angle identities and I can apply these. However, because I am squaring the square roots, I can drop the square roots. So I'm going to drop the square roots when I write all of this out. So because again, we've got the squared term here. Okay, so now what? Well, we've got to simplify this. So maybe take a second, you think on your own, how does this simplify? Write that out. So this simplifies as 1 plus cosine x over 1 minus cosine of x. Okay, so now, remember, I am trying to prove that this equals this. Any ideas of how we could get to this? Well, we have, I think, a pretty big hint here. We have 1 plus cosine. We have one of these. I obviously need to multiply that by itself. So I think the best idea here will be to multiply by 1 plus cosine x, which happens to be the conjugate of the denominator. So we're going to multiply all of that together. Again, I would recommend that you maybe pause the video here and try to finish this one. Hit play when you're ready. So if I work through this, so multiplying this all out, I have 1 plus cosine x squared, right? This times itself. And then the denominator, when I multiply all this together, this becomes 1 minus cosine squared x. And okay, so 1 minus cosine squared x, what is that? That is the Pythagorean identity, so that just equals sine squared x in the denominator, and this was what we were trying to verify. Okay, so let's take a look at one more. Cosine of x equals 1 minus tangent squared x over 2 over 1 plus tangent squared x plus 2. All right, so the general rule of thumb is that you want to start on the more complicated looking side, which I have to say this looks pretty complicated. And then we're going to use that general principle of, actually, so we have that these are already, these are already half-angle identities, so we can use the half-angle identity here. So as far as which half-angle identity do you choose, well, you're really not sure, right? So we're going to try this one and we're just going to see what happens. The one thing I like about this is that this particular identity is entirely in terms of cosine of A. These other two identities have sines in them. And if you remember, we are ultimately trying to prove that this whole thing will equal cosine of x. So maybe it would be a good guiding principle just to choose the identity that's already entirely in terms of cosine. Now, remember, everything is squared here, so I can drop this square root when I apply the identity. So when I apply the identity, here's my identity applied. And so now I have fractions, right? Fractions within fractions. And at this point, it seems like we know that we probably want to get rid of the fractions. So what should I multiply these by? What should I multiply these by to get rid of the fraction? I probably want to multiply these by 1 plus cosine x. So I'm going to distribute this 1 plus cosine x to this whole thing. Now, again, this gets to be a little bit complicated in terms of the algebra. So I would suggest you pause the video and work this part out on your own versus just having me show you so that this makes sense to you. So even if you made a mistake, at least you get kind of how this works. Okay, so 1 times 1 plus cosine x, and then this part here times 1 plus cosine x, that's going to leave me with 1 plus cosine x minus just the top part of the fraction. And then in the denominator, I'm left with 1 plus cosine x plus, and then again, I'm just left with the top of the fraction. So now here's where we're at. And so now we just need to go through and do the algebra here. So I'm going to look through this. It looks to me like the ones will cancel out. And then down here, the cosines will cancel out. So what does that leave me with? Well, when all is said and done now, when I just collect my like terms, I get 2 cosine x over 2. And hey, the 2's drop out, right? So then I'm just left with cosine x. And that was what I was trying to prove. So cool. Okay, so that brings us to the end of this video, guys. So thanks for watching. I'll catch you in another video.